Hello everybody, I will start my today another live coding session. So in today's video, I will solve this question. Maximize distance to closest person. Okay, so I actually solved this question before and I will try to solve this again. But today I will, impose one more constraint. So I will try to solve this question in the constant space complexity. Okay, that being said, I will get started. So I'm giving an array representing a row of seats where seat I is equal 1 represents the person sitting in the I seat, and seat I is 0 represents that the I seat is empty. Okay, so I'm giving an array, integer array, which represents the row, and for the cells which are 1, some person is sitting, and for indexes whose element is 0, no one is sitting, and seat is empty. Okay, there is at least one empty seat and at least one person sitting. Okay, Alex wants to sit in the seat and he'd like to make the distance between him and the closest person to him is maximized. Okay, return the maximum distance to the closest person. Okay, so I will be giving an array which represents the seat availability, and yep, there is at least one empty seat and at least one person sitting. So Alex can find the seat somewhere because there is one empty seat. And Alex would like to sit in the seat where the distance to the closest person is maximized. Yeah. So he'd like to, choose a position where he can sit as apart as possible from the closest person. And the output should be the integer, which is the maximum distance to the closest person. Okay. Oh, seems like I was typing something here. Okay. So let me think of example with this case. Yeah. So for one, someone is sitting, and I can say the possible, places where he can sit is he can sit at these positions because 0 represents an empty seat. Yeah, and obviously I can calculate the distance from here. So maybe this and this. So the maximum distance is 1. Yeah, for this maximum distance 2 because left is 2, right is 2. For here, left is 3, right is 1. So it should be 1. And for here, left is 1 and right is 1, so it should be 1. So I will return 2. Okay. Good. So that being said, the algorithm I can come up with is okay. So as the brute force approach, I will take a look at each seat. Then I will take a look at left. I will traverse from that index to the left as long as there is no one, or I should say until I reach someone. And also then in that way I can get the maximum distance to the left person, and the same way I will traverse from the current index to the right until I reach some person, and in that way I can find the distance to the right person. Yeah. Then the maximum of them minimum of them minimum of them is the distance until the closest person, and I will calculate that for each seat, and then we will return the maximum one. So the time complexity should be n squared because I will start from each empty seat, and in the worst case I have to traverse until the leftmost index or rightmost index. Yep. Okay, so that's the brute force approach. but probably I can speed this up. So yeah, I think I can use the prefix array for this question, and also suffix array. So prefix array represents the last person in the left hand side, and the suffix array represents the first person in the right. And once I calculate this prefix array and suffix array, for each position, I can find the distance in the constant time. Yeah. So in this way, time complexity should be O of n, because building the prefix array takes O of n time, suffix array is the same O of n time, and as I said, I will take a look at each empty seat, and I can get the distance in the constant time with prefix array and suffix array. And in total, it should take O of n time. And for space complexity, this should be O of n, because I need to build prefix array and suffix array. Yep. And I can say this time complexity O of n is the best achievable, time complexity, because I have to at least take a look at each seat in the given array. Yep. In any way. So now my goal is to reduce, optimize the space complexity to O of 1 constant. So let me think. So let's say in this case, I think the possible approach is that I use a kind of 2 pointers. So what I mean to say is the first pointer is pointing to the last one. Yeah, last person's position. And the second, or I should say, earlier pointer is pointing to the, next one from current 0. So this is, slow pointer, and this is fast pointer. And in that way, for example, if I'm at this 0, index 2, the slower pointer should be pointing to 1. And the faster pointer is pointing to index 1, 2, 3, 4. Yeah. So I can find that the distance from here is minimum of 1 or 3, which is 1. Yeah. And when I take a look at this, it is still the same. But once I reach 1, and then when I get 0, this one, this slow pointer is moving to here, and faster pointer is moving to here. And then I can calculate it. And one thing I can say for this solution is that, for example, if the Rx reaches this index, the slow pointer should be here, but the faster pointer is nowhere to point. So in this case, I would say max pointer is pointing to infinity. And the same way, when I'm at, say, like here, I would say slow is now pointing to, minus infinity. In that way, everything works. Because, yeah, if Alex is here, I can think that the distance to the closest left person is infinity. So the closest distance to some person is determined only by the left person's distance until the left person. because it's always smaller than the infinity, obviously. Okay, so that's my approach. I use 2 pointers, throw pointer and fast pointer. Okay. So let me think. And I think, even though I said I will use 2 pointers, I think I actually need only 1 pointer. Because for the thrower pointer, which means the previous one, I just have to keep track as the variable when traversing the current Alex position. So what I mean to say is, I will traverse current pointer as Alex, and here I can say previous is negative infinity, and here still negative infinity. Oh, sorry, I don't have to take care of this because, you know, this is 1. I just skip. But here I update the previous 1 to be index 1. Okay, and when he reaches index 2 here, still the previous one is now 1. Yeah, and from here I can find the distance until the left person by comparing current and previous one index. Okay, but as I said, I still need the early pointer. So one thing I can think is that every time Alex reaches somewhere like here, like 0, I start the traversal to find the early pointer, or I should say right person's point index. And this is not updated when Alex moves from here to, you know, here. But when he reaches here, it should be updated. So definitely I would move the earlier pointer under this. And once I move this until Alex reaches next one, it is not updated. Okay, so that's the kind of algorithm I can use. Yeah. So for next one, when Alex is 0, I will traverse and find 1. Yeah. Then Alex reaches here. I will try to find the next 1 position. So it should be 5. Then Alex reaches index 2. This is not updated yet. Yeah. Because, you know, he still the seed Alex has found is 0. Okay, that's how it works. So that being said, let me start the implementation. Okay, so this works in this way. And if this is 0, calculate distance update global max, okay, to be returned. Then I will return global max. Yep, so this is it. Okay, so in this way the time complexity should be O of n, because I moved 2 pointers, current and also next one. And for current one, it traverses from the integer 0 until the end of the list. So it takes O of n. And for next one, this moves independently from current index. And it starts from index 0 until end of the list. So it takes O of n 2. And after that, as I've written in line, that's it. Basically, as I move the current pointer, all the operations can be done in the constant time. So in total, it takes O of n time. For space complexity, this is constant because, I use only pointers. I don't use any non-constant data structure in this solution. Okay, that being said, I will start my implementation. If the current state is 1, I will update this. And also I will move the left point. No, next one. Okay, but let me do it in this way. So I will think of the case when current state is 0. In this case, Alex can see it somewhere. Wait. But to do that, I have to, find the first position of the current. No, next one. So if the first seed is 0, how can I find the next one index? Okay, so let me do it. This is quite trivial, but I will make it in some method. So I will implement this later. Anyway, the first position, next one is the first one index. And in line 52, now I can say if the current is 0, this. So what I will do next is, because I found the closest distance here, I will update the maximum distance to be returned. this is it, and then return. Okay. Okay. So this is the case when the current seed is 0. Otherwise, as I said, I just have to firstly update prev1 like this, and also I will update the next one. So let me, do that in the same way. Okay. Yeah, that's the thing I will do. For this, if I can't find the next one, then I should return mass.infinity. So that's a contract of this method. Okay, I will return it. So I will implement this. And I will implement another sub method. Okay, this is it. Yes. Okay, so let me walk through my code so quickly. Let me go with this example. Okay. So I will focus on the walking through. I will focus on walking through the main method. I will trust that the two sub-methods implementations are correct. If there's a problem, I will come back to them. But for now, let me focus on the logic of the main method. Okay, so here, n is initiated with 3 and prev1 is initiated with the first one, which is 0, and minus infinity, and next one is initiated with 0. Okay. Oh, by the way, expected distance is 2 when keys Alex set index 2. Okay. So in line 55, max process distance is initiated with negative infinity. Okay. Then in line 58, because n is 3, I will take the current 0, 1, 2, 1 by 1. When current is now 0, seed 0 is not 0. So I go to line 65, and prev1 is current. So it should be 0. And next one should be next one index. Actually, there isn't, so this becomes infinity. Okay. And I come back to line 59, and I will take a look at current is 1. Here, seed.current, seed current index 1 is 0. So I take a look at line 61, and left distance should be 1 minus 0 plus 1 is 2. No, this isn't correct. I don't need plus 1 here. The distance is just a gap. I don't have to increment by 1. Okay. So now left distance is 1 minus 0 is 1. And right distance should be infinity minus current, which is 1, is infinity. So closest distance should be 1. Okay, and max closest distance should be now 1. Good. And I go to line 59, and now current is 2. It's the last step. Because seed index 2 is 0, I go to line 61. And left distance should be current 1 minus prev 1, which is 0, which is, sorry, current is not 2. Current 2 and previous 1 is 0, so it should be 2. And for right distance, next one, which is now infinity, minus current, which is 2, is infinity. So closest distance is now 2. Yeah. So max closest distance is updated with 2, so this becomes now 2. Okay, and I return it in line 69. Good, so I can say this test case passed. Okay, so I'm pretty confident on my code, especially for the main method. I covered all the lines, so let me submit my code. Oh, sorry, it's current one. This should be just current. List index out of range. I see. So I forgot one case, probably. So if current one is at the end index, I cannot do this because current 1 plus 1 is out of the boundary. Actually, this becomes exactly n. But in that case, doesn't it work? Because n to n, sorry, it should be range. Okay, that's the problem. Good. Now I submit my code. Okay, accepted. Great. Okay, so I quickly wrap up my today's coding session. So today's question was maximum distance to closest person. And in this question, I'm given an array, seats, which is binary integer array. And the number 0 represents the seat is empty, and number 1 represents that the seat is occupied by some person. And my task in this question is to find the best position for Alex, with which Alex, the closest person from Alex, that distance should be the maximized. Okay. And for this question, I came up with 3 solutions. The first one is brute force approach, which took O(n) squared time. The second one is optimized approach, which uses the prefix array and suffix array, and it takes O(n) time, but the space complexity is still O of n. So to solve this question with O(n) time complexity and O of 1 space complexity, I used the 2 pointers. Basically, I had to move the current pointer and next 1 pointer. And also I kept track of the previous one according to the current index. With that being said, for every position, I can find the maximum distance to the closest person from Alex in the constant time. and I just had to return the maximum of them, and it worked. Okay, so that being said, I finished my today's coding session. Thank you so much. Bye.